Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this lecture we are going to discuss a few other outlier detection approaches. So we'll be going to cover the concepts like a grid-based method, density-based outlier detection, and clustering-based approaches, classification, and the outlier detection in the high-dimensional data also. So clustering-based approaches detect the outliers by examining the relationship between the objects and the clusters. Intuitively, outlier is an object that belongs to the small or remote cluster or does not belong to any cluster that would be treated as an outlier. So a distance-based outlier detection method consults the neighborhood of an object, which is defined by a given radius. So an object is then considered as an outlier if its neighborhood does not have enough other data points. Whereas the density-based outlier detection method that investigates the density of an object and that of its neighbors. Here, an object is identified as an outlier if its density is relatively much lower than that of its neighbors. So like suppose let us take data one group and let us take another group, and if you compare the densities, and the density of this is completely different. So a grid based method that is called as a cell is used. It is mainly uses the distance based outlier detection method. So in this method, the data space is partitioned into the multi-dimensional grid, where each cell is a hypercube that has a diagonal of length r by 2, where r is the distance threshold parameter. So distance-based outliers is another method, that is a dB of r, 5 outliers are used, one type of outlier. Specifically, distance-based outlier detection takes a global view of the data sets. Such outliers can be regarded as a global outliers for mainly for the two reasons. One is a dB, the distance-based outlier detection method, for example, is far from at the least 1 minus 5 times 100% of the objects in the data set. In other words, an outlier as such is remote from the majority of the data. And the second reason is to detect the distance-based outliers, we need the two global parameters r and pi, which are applied to every outlier object. So many real-world data sets demonstrate a more complex structure where objects may be considered outliers with respect to their local neighborhoods rather than with respect to the global data distributions. So whereas a clustering-based approaches, the notation of clusters is highly related to that of clusters. That is, clustering-based approaches detect the outliers by examining the relationship between the objects and clusters. Intuitively, an outlier is an object that belongs to the small and remote clusters, as we already discussed in the previous lecture. It does not belong to any cluster, or it may belong to the very small clusters. So this leads to three general approaches to the clustering based outlier detection. That is, if you could consider an object like does the object belong to any cluster? If not, then it is identified as an outlier. And the second one is there a large distance between the object and the cluster which it is closest? Then if it is yes, and that would be considered as an outlier. So is the object part of a small or a sparse cluster? If the object part or of a small or the sparse cluster, if yes, then all objects in that clusters are considered as outliers. So another classification based approaches, that is to detect the outliers, can be treated as a classification problem if a training data set with a class label is available. So the general idea of a classification based approach outlier detection method is to train the classification model so that can distinguish the data from the outliers. So consider a training set that contains samples labeled as a normal and other labeled as a outliers. So a classifier can then be constructed based on this training set. So any classification method can be used. So this kind of brute force approach, however, does not work well for the outlier detection because the training set is typically heavily biased. As I said, the outlier, the samples, number of samples which are labeled as outliers would be very small compared to the number of samples which are labeled as a normal. So the number of normal samples likely far exceeds the number of outliers samples. There is a heavy imbalance. So this imbalance where the number of outlier samples may be insufficient can prevent us from building an accurate classifier because there will be no enough information or knowledge about the outliers. So consider, like for example, intrusion detection system, because most systems accesses are the normal. So it is easy to obtain a good representation of this normal events. However, it is infeasible to enumerate all potential intrusions as a new and unexpected attempts occur from time to time. Hence, we are left with a insufficient representation of the outliers or intrusion samples. So to overcome this challenge, the classification based outlier detection methods often used as one class models. That is, a classifier is built to describe only the normal class. Any samples that do not belong to the normal class are regarded as outliers. So that is one sample, and the rest of all the samples would be treated as outliers. So in some applications, we may need to detect the outliers in a high dimensional data also. That is, the dimensionality cuts poses the huge challenge for effective outlier detection. As the dimensionality increases, the distance between the objects may be heavily dominated by the noise. So that is, the distance and the similarity between the 2 points in a high dimensional space may not reflect the real relationship between the points. Consequently, conventional outlier detection methods, which mainly use the proximity or the density to identify outliers, deteriorate as a dimensionality increases. So let us quickly summarize about this outlier detection, what concepts we discuss, what are the key takeaways from this section. An outlier is an object that deviates significantly from the rest of the objects as if it were generated by the different mechanisms. So there are three types of outliers, like including global, contextual, and collective. An object may be more than one type of outliers. So whereas global outliers are the simplest form of outliers and very easy to detect. Whereas a contextual outliers deviate with significantly with respect to the specific context of the object. So a subset of the data objects forms a collective outlier if the objects as a whole deviate significantly from the entire data set, even though the individual data objects may not be outliers. Whereas the challenges in outlier detection include finding appropriate data models and the dependency of outlier detection systems on the application involved, and finding ways to distinguish outlier from the noise, and providing justification for identifying the outliers as such, that is to understandability. Outlier detection methods can be categorized according to whether the sample of the data for analysis is given with the expert provided labels, that is, that samples with the labels or without labels can be used to build outlier detection models. Thank you all.